We have seen in the last video that if we use traditional standard calculus 2 methods to evaluate this improper integral from negative pi by 2 to pi by 2 of tangent of x, we get a infinity minus infinity situation, and you would just say that this improper integral diverges. However, if we decide to use the Cauchy Principal Value, we will see that we can get a conclusive result. So here's the deal. We're still evaluating the same improper integral, and the graph is still going to be the same. Except that now we're going to use the Cauchy Principal Value, essentially taking chunks of epsilon distances away from negative pi by 2 and pi by 2. So right over here, we set this number epsilon. Epsilon is greater than 0. So right over here, the distance from negative pi by 2 to this red point over here is going to be negative pi over 2 plus epsilon. And over here, it's going to be pi by 2 minus epsilon. Essentially what we're doing is that we're trying to evaluate the improper integral by making it so that this asymptote, or not asymptote, but this line of where epsilon lies on, or the distance from these two non-permissible values to this point, we're trying to make it so that this point, or this line I should say, sorry, I'm stumbling right here. I'm making this blue line getting closer and closer to this vertical asymptote, and I'm making this blue line closer and closer to this vertical asymptote. So essentially, I'm trying to take the limit as epsilon approaches to 0 plus, such that this blue vertical line, these two vertical lines, are gonna get closer and closer to their corresponding asymptotes. So let's try that. So the Cauchy Principal Value of this improper integral, okay, so we're going to take the limit as epsilon approaches 0 plus. So right over here, this lower end is going to be negative pi by 2. So the lower end is negative pi over 2 plus epsilon. The upper end is 0. Well, actually, technically, I could evaluate this from, instead of splitting it into 2, I could just say it equals to this whole thing. From negative pi over 2 plus epsilon to pi over 2 minus epsilon of tangent of x dx. I evaluate this, and this is equal to the limit as epsilon approaches 0 plus of the natural log of, I'm going to say the negative natural log of the absolute value of cosine of x evaluated from negative pi over 2 plus epsilon to pi over 2 minus epsilon. If we just plug in these numbers, or these values I should say, so we get the limit as epsilon approaches 0, negative natural log of the absolute value of cosine. So this is going to be pi over 2 minus epsilon. Okay. And then right over here, we're going to add, right, minus minus is plus. Right. Log absolute value cosine of negative pi over 2 plus epsilon. Now here is the best part for this question. Right over here, actually let me just write down this limit as epsilon approaches 0 plus. Okay, so let me just keep the first one the same. Ln of absolute value, negative ln absolute value, cosine of pi over 2 minus epsilon. Now here's the deal. Cosine of pi by 2, this is gonna be 0. Okay, so for this part, as epsilon approaches 0 plus, cosine is gonna approach pi by 2 from the right, which means that this the input, this pi over 2 minus epsilon is going to approach pi by 2 from the right, which means that cosine of this input is going to approach 0 from the right, which means this ln is going to be negative infinity, but then you got a negative negative, so it's positive infinity. And then over here, you're going to have like a negative infinity situation. So then you'll be like, okay, we're back to this situation again. Oh, sorry, I erased it. The negative infinity plus infinity situation. Now here's the good thing about the Cauchy Principal Value. Instead of first evaluating the limit and then combining terms, you first combine terms and then you solve for the limit. So essentially what you're trying to do is that you're first simplifying this expression before taking any limits. Okay? So at the end, you're still going to take a limit, right? Then you are going to first simplify this expression right over here. So here's the deal with the second part right over here. If you factor out the negative term from the input of the cosine, you have negative of pi over 2 minus epsilon, right? Negative of pi over 2 minus epsilon. Okay. And what is amazing is that right over here, you have pi over 2 minus epsilon. Right over here, you also have pi over 2 minus epsilon. And if you know from your rudimentary trig identities that cosine of theta is equal to cosine of negative theta, right? Because cosine is an even function. So what does this mean? It means that this cosine of negative pi over 2 minus epsilon right over here can be rewritten as pi over 2 minus epsilon. Now, look, you have a plus ln absolute value cosine pi over 2 minus epsilon minus ln absolute value cosine pi over 2 minus epsilon. These guys just cancel each other out, so what you're left with is a big fat 0. So essentially what you're taking is that you're taking the limit as epsilon approaches to 0 plus of a constant 0. This is simply just equal to 0. So using the Cauchy value, we were actually able to determine that this area, tangent of x from negative pi over 2 to pi over 2, even though it's not bounded, right? Well, it is bounded by a vertical asymptote, but it's not continuous at pi over 2 or negative pi over 2, right? Even though we get the answer diverges using standard calculus 2 improper integral techniques, by using the Cauchy Principal Value, we were able to finally conclude that this area is indeed equal